The rectangular coordinate system is the very basic and a very commonly used coordinate system. So it is very commonly used, and it is also easy to use it. Commonly used system to locate any point in the space. Usually these this rectangular coordinate system, usually you have it been represented as an xyz axis. It will be represented in xyz axis. So as I told you, you have the xyz axis here, and if this is going to be a space, so this is a space, the white box space where the object is located. So at this corner I'm saying this object or the charge q is located here. So now I can what I can do is I can draw a line, or I can show in this way. Okay, yeah, in this color I show you. So from this q, from x, this is x, this is y, and this is z, and this q from x is like in this position, right? In this position you can see the line, green line, from the point of x, and for the y the position is somewhere here, and for the z you have the position somewhere here. So you can see the intersection point. So this q can be represented as a point where the intersection of xyz axis, which is drawn perpendicularly from here, it is being noted. So it may not look like a perpendicular line, but it is a perpendicular line. That is, you have to draw a perpendicular line from the axis so that it reaches the point correctly, right? So this is how it is done. So that's why you will get the length of the that is the distance. So usually, for example, in various conditions, we will say if the point somewhere I say it is 2 comma 3 comma 5, they give it as 2 comma 3 comma 5, where 2 represents the x value, and 3 represents the y value, and 5 represents the z value. So based upon this location, it can be located for an xyz coordinate. And so this is a rectangular, this is how the rectangular coordinate system is usually being described in this. The next one is the cylindrical coordinate system. The cylindrical coordinate system. So in the cylindrical coordinate system, the instead of x, y, z, here we have r, phi, and z. R, phi, and z, where r is the radius, phi is the angle, and then the z is the the z plane. This is one of the axes. So here how it does it look like? It is circular cylinder is the space mentioned for you. Circular space cylinder is the space mentioned here, and you have this axis. We take it as this as z, and this as the radius r. And suppose if I say I have a point charge somewhere here q, then I mean to say, so let me draw it like this for convenience. Sure, I'll draw like this. Okay, my axis is somewhere here. Okay, now it's correct. I'll take it as C. So now your point q is somewhere at a distance z from this origin, z value from this origin, and the next one is it is at a distance about r is also included, which is the radius, because you have a cylindrical somewhere like this, and an angle is formed, from the origin, which is an angle of phi. So you can now represent this q charge, we can locate this point of q charge with respect to r, phi, and z. So here r stands for this radius, and phi stands for, it's called as angle, and this is the plane. So in cylindrical coordinate system, you should if you give a if something is expressed in terms of r, phi and z, then you have to understand this is cylindrical coordinate system. The last one is the spherical coordinate spectrum. In spherical coordinate system, it is very easy to know that here the three parameters which is involved is one is r, then theta and the phi. R, theta, phi are the three important parameters, as you see x, y, z in the rectangular and r, phi, z in the your cylindrical, and now spherical coordinate system you have r, theta and phi. So this is the basic understanding. You can go through this spherical this coordinate system in mathematics so that you can understand much more on this coordinate system. So above all, we need to now find the relationship between the Cartesian, cylinder and spherical, because there are some problems we've been asked in the examination which you need to convert the from one form to another. For example, if you want to find the Cartesian system or the rectangular system, usually this Cartesian system will be represented as x, y, z, and if the other two are given, other two coordinate system are given, like cylindrical, the cylindrical and spherical, if both are given, in the cylindrical you should have r, and z, and then the spherical you will have r, theta and phi. Okay, so if suppose they are asking you to find the xyz value by giving a cylindrical system, you should be able to find it. So let me tell you how to find the x value. If you want to find the x value and you are given with a cylindrical coordinate system, the formula is r cos phi, r cos phi. So in the same thing, like if you want to find for y, the value of y can be found as r sin phi. And for z, we know that for the cylindrical coordinate system the common thing is z, as same as the Cartesian system, so z remains the same, z remains the same. And when coming to the spherical coordinate system, if you have r, theta and phi, if you want to find the x value, the formula is r sin theta cos phi, and if you want to find y, you have r sin theta sin phi. And for the z, you need to find there's nothing common here, so r cos theta. So this is how you can find the values of xyz when the cylindrical and the spherical values are given to you. This you will have some 2 marks problems, or even in the bigger question you need to convert from one coordinate system to another coordinate system. So next we will see about how to convert. What if I am being given with a other rectangle Cartesian, if I am given with a Cartesian and a spherical, Cartesian and spherical, and I am being asked to find what is the cylindrical coordinates. You know that in the cylindrical coordinates you have r, phi and z, and in the Cartesian you have x, y, z, and in the spherical you have r, theta and phi. So we want to find this. So first, if you want to find the value of r using the Cartesian system, the value is x square plus y square the whole root is the value. And if you want to find the phi value, the formula is tan inverse y by x, and we don't involve the z in both the cases, and even for finding r and for the phi we don't involve the z, just because the commonly used is z in both the cases. So you have z, s, and here z can be the same value for both the Cartesian and cylindrical. The same way in spherical, if I have given with the spherical values and you need to find the coordinate system for cylindrical, you have the formula is r sin theta, and for the very common thing is this phi value, and if you want to find again the phi value, that remains the same phi. And for the z is not common in both the cases, so you have r cos theta is a common. So it's very easy to remember all these 3 cases, and it is more important. And finally, if they are asking you to find the spherical coordinate system by giving the other 2, Okay, so let's see how to what's the formula here. So you've been asked to find the spherical, and you need to find the cylindrical, and you have Cartesian here. So in cylindrical you have r, phi and z, and Cartesian you have x, y, z, and in the spherical you have r, phi and theta. Okay, so let me tell you how to find it. So if you want to find r value, we have cylindrical given, it is r square plus z square is given. This is the formula. And if you want to find the value of phi, for the cylindrical you have cos inverse, the denominator you have the root of r square plus z square, the numerator have z. And if you want to find the theta, so theta is there is nothing common in this, so we have we have to find the theta. I will have this. The theta is found like this. Theta here is found as phi value is found because phi is very common here. Phi is very common, so phi is common. In Cartesian, from Cartesian to spherical, if you want to find r value, the r value can be given as x square plus y square plus z square, the whole root. And to find the theta, it is nothing but the cos inverse of this x square plus y square plus z square in the denominator, and in the numerator you have z. And to find the phi value, it is cot inverse x by y. Okay, so cot inverse x by y. So these three tabulations are more important, where it describes you how to convert or how to change from one, or how to represent one coordinate system with respect to the other. So you should know all these three very well, so that it will be useful in the problems or doing any derivations in the forthcoming lectures as you study. Thank you.